Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's episode, I'm joined by Stefan Permien from UniverCell in Germany. Stefan's got a really interesting story, and UniverCell is a new company, but with very, very interesting history and some really bright prospects. So, Stefan, welcome to the show.
Yeah, thank you, Ryan. So, thank you for being here.
Is it possible, Stefan, just for you to give us a quick introduction and tell us about your personal background and how you got to be doing what you're doing now?
Yes, of course. So, my name is Stefan Permien. So, I started more than 8 years ago to develop my love to the lithium-ion batteries, I would so call it. It was, I started chemistry, so this is where it all begins. I started then getting in touch with lithium-ion battery technology during my diploma thesis. And after that, I was totally focused because I thought, okay, this is a technology that can bring the future to a whole new level. And saving energy and getting it whenever somebody needs energy. I think this is a great thing. And so I did my PhD thesis in this area. And then after my PhD, I started in a startup called Custom Cells Itzehoe. And there I was CTO for more than 3 years. And after my time there, I started my own company, UniverCell, and this is where we are today here now.
And one thing that's interesting for me, we speak to a lot of people on the podcast, but mostly they are engineers. Not often we get a proper battery chemistry guy on the shows. So would it be possible then just to tell us a bit more about what you're doing at UniverCell, what the business is about?
Yeah, of course. So it all started more or less I was totally in the market. And in the market, I saw two developments. On the one hand, there are the big lithium-ion battery producers, which are totally driven now, to be honest, by the automotive industry.
Yeah.
And the automotive industry, of course, it's the largest piece of the cake in the future. So they are focused on that. But there are a lot of other markets. And these markets, this is the focus of UniverCell. Because these markets, of course, are smaller than the automotive industry.
Yeah.
But they are also very interesting. For instance, medicine technique and also stationary storage capacity for renewable energies. Okay. All these markets are very interesting and they need other types of batteries, in our opinion.
Okay.
Because, for example, if you have stationary energy, you need much more cycle life compared to other industries like automotive.
Right. And when you say just so medical, what kind of things are you meaning in medical? Things that go inside people's bodies, or more like equipment that they would use in hospitals and such like?
Yeah, it's both. So on the one hand, you have now medical applications where you have machines, and normally you are lying in the bed at the hospital, and they have a guy that drops you with the bed together to the machine.
Yeah.
But in the future, there will be machines that are coming to your bed, and you can stay there where you are.
Yeah.
So this is one type of medicine application. But on the other side, you're totally right. So we are together with the customer that is implanting cells and batteries into bodies. So in the end of the day, it's in your body, and therefore it's very good if you have a safe battery and not something that burns in the worst case, or you have a problem with the electric power of these batteries. So quality is much more important than high energy, for instance.
Oh wow! So so you've set up a battery manufacturing company, and that's a huge thing to do, in terms of a startup business. It's not an unambitious thing to be doing. So what made you think about that? Because you are actually, I know when we spoke a couple of weeks ago, you were setting up production lines and things. So you're like proper making stuff, right?
Yes, exactly. So of course it's a tough decision to start a startup in the battery industry. But just from my background, so I was in the past, I was a sportsman, professional kite surfing guy.
Oh wow! Cool.
Always at the ocean.
Yeah.
And this is something where also everybody says, okay, this is crazy. Don't do that.
Yeah.
And maybe coming also from this background, it's the same for lithium-ion battery industry.
Yeah.
So what we think is it's at the moment the exactly right time to start business in this area, because the market is growing very fast. Everything is getting very fast. So there's a small time window, and we think this is exactly now. To be part of the market. So this is one thing that drives us. And the second one, to be honest, is here in the north of Germany. We have everything's full of these windmills.
Yeah.
And these windmills, of course, if the wind is blowing a lot, are spinning, which is very nice. So there's a lot of renewable energy. But if the wind is blowing the whole day, in the middle of the day, everything stops. And you drive through the landscape and you think, why all these windmills are just standing still? It doesn't make sense.
Yeah.
And then you ask yourself, okay, why is it so? And you go to the internet, you go to Google or whatever, and you check. And there you can see that everything is switched off because of the smart or of the grid.
Yeah.
Because it's not able to use this energy. And it's not the second thing is that it's not, the grid is unstable, and you can bring all the energy from the north to the south of Germany where it's normally needed.
Yeah.
So one big thing for us is to store this energy somehow on the one hand, and also to stabilize the grid on the other hand.
Oh wow! And that's a huge. You're talking gigas and gigas and gigas of watts of requirements for grid. So in your, just to, because we're going to get onto some of that, but just to sort of finish off, in your plant, so manufacturing company, new manufacturing company, which is, it's so fantastic, because a lot of people would be like doing consulting or what have you, rather than actually making that big bold step of putting the process equipment in. Could you tell us a bit more about how much of the process you've got inside the business?
So we also, as you know, or everybody knows in the business, you need a lot of money to build up a whatever factory. Even not a gigafactory is taking already a lot of money. So we thought, okay, how we can have a first step in the market.
Yeah.
Because we were exactly at the same position. So we had a lot of knowledge. We were able to do it. We were able to consult people.
Yeah.
But we didn't have machines, so we can't produce.
Yeah.
And so we thought, okay, how to get the first step into the business? And our first step into the business is to coat the electrodes. As you know, the electrodes are the main part of each cell, and all the energy stored is in the electrode. So if you want to have a good performance of your cell, the electrode is the key element to have a good cell.
Yeah.
And coming from this knowledge and this idea, we started to produce electrodes. And this is exactly where we are right now.
Okay.
So what we can offer to our customers is electrodes in different ways. We can have a continuous coating, which you need for pouch cell design, for example. But we can also do an intermittent coating, which is very important for prismatic or for cylindrical cells.
Right. Okay. And then will you do the rest of the cell assembly inside your business at some point, or do you do that now, or will you always just make the electrode and then send it to someone else for the final production into the cell?
Yeah, the status today is really we produce the electrode and we can send it to partners and build the exact right cell, which means no matter if you want to have a pouch cell or a prismatic cell or a cylindrical cell, you can have our electrode inside and get the cell dimension and the cell format you want to have.
Wow.
So which is a very huge step in flexibility, I think. And in the future, of course, we will do somehow or some type of cells. That will be for sure. But nobody in the world can do like cylindrical cells and pouch and prismatic in the same very good quality. Not even the big players can do it.
Yeah. Okay. So you will you wait and then pick one at some point, and depending on what the application is, and then you'll go with that. Yeah,
there we go with our customers together. So everything what we are doing, like electrodes, but also cells and modules, are together with our customers.
Okay.
So depending on the customer needs, we will develop to one or two types of cells.
Okay. And you've got some pretty special stuff in terms of actual different types of electrode as well, haven't you?
Yeah, exactly. So normally a factory is totally focused on one type of chemistry combination, which means on the high energy level, you have typically in Europe, the NMC with the nickel-rich cathode materials and a silicon graphite combination for the anode side. What we can do with our flexible coating line is that we can produce each standard electrodes on the anode and on the cathode side, which means we can also do the NCA, we can do also the lithium iron phosphate, and on the anode we can do graphite as well as silicon and of course the lithium titanate if you want to have a lot of cycles. So there we are very flexible, and we have also customers asking for even more crazy stuff, like we have lithium sulfur combination. We have now a project where we try to coat pure silicon stuff, so that we have there no graphite anymore in the anode.
Yeah. Okay.
Which is an interesting topic for the future.
Yeah.
As well as we have now a partner which is doing sodium ion. So getting away from the lithium to sodium. As you know, sodium is much bigger and heavier ion.
Yeah.
So it will be nothing for automotive.
Yeah.
But it's interesting for stationary application, for example.
Okay.
No worries. So now you see the circle is closing. As I said in the beginning, we are focused on non-automotive markets.
Yeah.
So we are also checking these topics.
And on the process side, it's a wet process. So you're doing like kind of mixing and applying that sort of way?
Yeah, so the mixing process on the lab scale and pilot scale we can do on the typical batch processes that from all the presentations. Like mixing in a big planetary mixer and then having a huge batch of slurry.
Yeah.
But we have also a continuous mixing process where we work with extruders. And we think this is a very interesting thing in terms of quality also. So we see a better quality in the slurry on the one hand, and what we also see is we can skip or keep away some solvent amount there.
Okay. That must be pretty cool. That must be pretty interesting. You're doing really big chemistry in the labs, making huge batches of different combinations of materials. Do you get to be hands-on still with that, or are you taken away with more the running of the business?
I always try to keep my hands on, because I love it so much to see the production, see the machines running. It just makes me happy if I'm there and I know that actually something is produced. And I like it to discuss with my engineers on the processes, with my chemistry team on new slurry recipes and so on, because this is where I'm coming from. But of course, as a CEO of such a big company now, the days in the lab and in the production area are getting less and less. Because there's a lot of things on the sales and on the marketing, and as well as in the financial part of the game.
Yeah, and you get these really annoying people that try and drag you out to do podcasts as well from time to time.
Yeah, but such a thing I love. So
very good. It's fantastic to see. I just wonder what were the major sort of challenges in terms of when you guys came up with this plan to set up the plant. What have been the big challenges that you've had to overcome to get to where you are now?
Well, there was a lot. So the first of all, of course, if you are a startup and you and your co-founder are coming into a pitch, or you want to rent a production building or whatever, you're young, and the people are not taking it seriously. They are thinking, okay, these are two crazy guys having a PowerPoint, whatever. Let's keep them talking, and that's it. So this is a big problem, but we overcome this, and now people are taking us much more serious, because we have a production building, we have a lot of machines in it, and this helps a lot to have something physical there.
Yeah, people like that, where you even if you've got a very clear vision of what you're going to do, I think people don't tend to believe it until they actually see it. So being able to come up and sort of kick it and touch it is very very helpful for people, certainly.
Yeah, and second thing, what was very challenging was, so of course we have this pandemic, we have this COVID-19 everywhere. And as you know, the best machines for lithium-ion batteries are mainly coming from Asian region. So we bought a coating line, to be honest, from Japan. And so this, you have to imagine, this coating line is coming in. It was 5 very big trucks full of wooden boxes with so much stuff in it. So what we did, we brought it into our production hall. It was a whole mess to open all these wooden boxes, because there was wood, pieces of wood like everywhere. And then we brought in these big parts of the coding machine, and we asked the machinery supplier, how can you send us engineers to help us to bring it on? And they said, no, not now.
Yeah.
So Europe is not the best place at the moment to get people here traveling to us, and therefore we had to find a solution. And what we did, we did almost everything by our own. You have to imagine we had some plans, of course, coming from Japan.
Yeah.
With a lot of Japanese signs in it, which we didn't understand. So that was very challenging. But in the end, we managed it, and we have a great team here with engineers which are very focused on the solution, and which is a lot of fun to work with these guys every day, because we set up now the pilot coder in just 6 weeks.
Wow.
So this is really amazing.
And how have you found it? One of the challenges I often see people doing EV stuff, it's a new area, and there's, it's hard to find people who've done, there can't be many people in your area in northern Germany who've set up a battery manufacturing plant before, because there just aren't. How have you found it in terms of finding people that have got the right skills?
It's often difficult, but I think you have to open your mind a little bit more. If you just focus on searching people that already set up a battery plant, of course, this number of people is so limited.
Yeah.
But you have a lot of other technologies. So if you have, for example, mixing technologies, mixing a slurry can be the same like mixing other things, like other pastes and other stuff. So we are not searching for a battery slurry mixing guy. We are searching for a mixing guy for whatever. So this makes us a little bit open-minded and helps us a lot to find the right people. And the second thing is we are here in Flintbeck, which is very close to Kiel.
Okay.
And Kiel is a very, very young city with 3 different universities.
Right.
And this helps us so much because people are coming here and studying, and we can get to know these people and get it directly from university, which helps us a lot getting new open-minded people for our factory.
Oh, fantastic. And so what sort of, what are your customers like? What kind of companies are you dealing with there? You mentioned some of the markets that you're in, but I don't know if you could tell us a little bit more about some of your customers.
Yeah, sure. So our customers for the electrode foils are mainly from the US and Europe, and are small and mid-sized producers of cells as well. So they have mainly special cells in the portfolio, I would call it. Yeah. And they have a clear vision how an electrode should look like. And this helps us a lot also to develop more and more knowledge.
Yeah.
This is one type of customers. Then we have another type of customers, which is more innovative driven, I would call it. So they have, as I said, new chemistries, which they want to scale up from the laboratory to a mid-size or large-size production.
Right.
And to have this facility here from us helps them a lot, because they don't have to make the same invest as we had already done. So we are working together hand in hand, And we are trying to make the best electrodes for them with our state-of-the-art equipment.
Brilliant.
Which helps them a lot to show their investors or their shareholders that their technology is also something for the future.
Yeah. So that's a really nice segue into my next question, which was about the future and what you kind of see as being, for you guys in your part of the market, what do you think the next kind of big developments are going to be that you will be involved in?
Well, that's such a tough question.
Sorry.
Because there's so many new technology. As I mentioned, you have this sodium ion technology. I like this because it can lower the price a lot.
Right.
And on the disadvantaged side, I'm totally honest, it will never be something for the automotive industry because it's too heavy. So this is really just for stationary energy storage. Then you have this lithium sulfur, which is, I think, very interesting for drones, for example.
Okay. Why is that?
Yeah, you have a very high energy on the gravimetric level. So if you look on energy density in the automotive industry, of course, cells are heavy and batteries are heavy, but the main problem in automotive industry is more the volumetric energy density. Okay. So this should be lower in automotive. And in drones or flying objects, the gravimetric energy density is the most important. And therefore, you can have this lithium sulfur, which I think is a nice thing for the future, because in the drones, you have also smaller cells. And in the fact that something is happening, it doesn't have such an impact compared to automotive battery where the whole car then has a big problem.
Yeah. Okay. That's really cool. And the fundamental kind of the sort of chemistry behind those is it like completely is the same principle basically as a automotive cell, just with a different chemistry, or are there kind of different operating sort of mechanisms going on there?
Yeah, it depends a little bit on the application. Okay. So I think automotive will be focused on more or less big cells. Right. So you have these big prismatic cells, you have the cylindrical cells, which are going bigger and bigger. As you know from Tesla's battery day, even Tesla is searching for bigger cylindrical cells. And the same is it for the pouch cell. If you have a look on the pouch cell, which is in Mercedes-Benz or in the Porsche Taycan, it's a big pouch cell. Yeah. And all these gigafactory will focus on that, and you will have only big cells coming from this gigafactory. So this is a big problem in all these smaller applications. Like medicine applications where you need smaller cells. Yeah. Even if you look on the voltage level, for example, if you have just big cells, the voltage level is you have to increase this number of cells a lot to have a big voltage level. Yeah. Which needs a lot of space and so on. So there will be applications. The batteries are totally in the wrong dimension. Yeah. And then you will have another topic concerning building batteries. So in the car, often you have a liquid which is cooling the batteries. Yeah. Which is, of course, necessary because you have this, if you accelerate, you need a lot of energy. So you have somehow cool down the batteries. And but there are many applications where no liquid cooling is possible, or it's very difficult, and therefore you need totally other types of cells and battery pack design, I think.
Okay.
Because if you, for example, lower the internal resistance of a cell, you have, of course, less thermal heating.
Yeah.
And then you can keep away all these factors like liquid cooling and so on. So so we are starting in the electrode and try to make the best design in the electrode.
Yeah.
Then go to the cell, have a look on the cell, and try to find the best dimensions and the best way to do it in terms of life cycle and internal resistance and so on.
Yeah.
And then in the end, we look also on the module and battery level to try there to find a good solution for the customer.
Okay.
And I think this combination gives our customer in the end a very huge USP.
Yeah.
Because all these customers somehow are in a market where all the other companies also use batteries. And if you just buy batteries from standard, you don't have an USP in your market.
Yeah. It's interesting, isn't it, that because there's literally billions of dollars of research dollars gone into the automotive side, and it's really, the lithium battery development has come along leaps and bounds in the last 10 years because of that investment in automotive and the production scale, and it's driven costs down. But I think a lot of people would assume that the batteries that were used in or starting to come into other applications like drones or like energy storage would be the same or similar. So it's interesting. It's a really interesting observation that you make in terms of some quite big differences on the different batteries and the design for those different applications. So what if I can ask, hopefully you can tell me, what's your kind of view of companies like Tesla, where they are, or certainly at the moment, using the same cells for grid storage as they are in the passenger vehicles? What's your opinion of that?
Yeah, to be honest, the Tesla company, I think they made so much possible in our business. So This is why I'm so thankful to Tesla.
Yeah,
because I think the German automotive industry never woke up, but Tesla showed them how to build an electric car somehow.
Yeah,
and I'm saying this as a German guy.
You may get a bit of stick for that, but yeah, I know totally what you mean. Really, now I think any doubters that were out there have conveniently forgotten that they ever thought it was a bad idea on the passenger vehicle side. So the truck side is different. Still a lot of people, but the Tesla effect, it definitely turned a few heads and opened up the market. And I'm sure there's more than one car company where basically their electric vehicle strategy started when they got the senior guy in a Tesla and showed him what it could be.
Exactly. So this is why I'm very thankful to Tesla to help us to develop our market somehow.
Yeah.
But what I see, and there I think Tesla is moving not so more or less in the same direction. So as I said, I think I prefer to use different chemistries, to be honest.
Yeah.
So if you have an automotive industry, you have full electric car. Of course, energy density is the best way or the highest goal to reach.
Yeah.
And therefore, you can take another chemistry compared to a stationary energy storage system.
Yeah.
But as you know, now Tesla is also moving, I think, in the Model 3 to lithium iron phosphate because it's much cheaper. I think it's mainly used in the Chinese market.
Yeah.
Therefore, they are now also more open-minded and also using and trying new chemistries. So therefore, I think it's going more or less in the same direction. I think in the future, I could imagine that the power wall has not the same cells like in a high performance Model S.
Yeah, and these big, because they've got some pretty massive grid battery systems as well in Australia. They've got some in the US. I'm not sure. I don't know if they've got any in Europe or not. I'm sure if they haven't, it's probably just a matter of time. But huge grid. So exactly the kind of application you were talking about with the to sort of support wind turbines and things like that. So yeah, it's really really interesting. So aside from Tesla, then a question people are always sort of saying, the battery industry is dominated by Asia. And you kind of alluded to that a little bit at the start because you said, you got your production line from Japan. And there's maybe a sense, some people think that, they were very fast in Japan and in China, particularly South Korea, to start commercializing this lithium batteries and putting scale into the production. Do you think that Europe can still hold its own? Do you think we've got something we can still offer? Can we be competitive against the big Asian players in that market? What's your view on that?
Yeah, totally. So on the one hand, as you mentioned, you're totally right. So our coating line is coming from Japan, but cell assembly line, we are talking to a German supplier. Right. So there is some know-how in Europe, not only German. There is a lot of know-how there, and they also this company, for example, is also selling to Asian cell suppliers. So on the machine supplier level, there is knowledge, and there are companies in Europe which are already state of the art.
Yeah.
If we then have a look on the cell manufacturing level and on the big production lines, I totally think that we can be state of the art and we can be exactly same level like the Asian companies. Okay. I think the only difference is that and this is, I think, a European general problem, that in Asia as well as in the US, people are investing more money to things they believe in. Yeah. And they just investing these money only believing that this is a nice story.
Okay.
And this helps, I think, in the US as well as in Asia, mainly in China, to build up these small and mid-sized companies, because this is a lot of money already, and you just have to believe in it. If you don't believe it, you don't invest, and then a small and mid-sized company will never be there and never be founded. And then coming from a mid-sized company, if you have a look on the biggest player on the market, it's CATL from China, as you know. So this company, I think they started with just a very, very small plant, and then they got more and more contracts, and then somehow they get a big contract with Apple, I think. And this was their starting point, developing from a mid-sized company to a global battery player, or to this global battery player.
Yeah.
And there, just in the beginning, you have to believe in the market. You have to believe in the guys which are driving this type of company, and then, of course, we can be one of the biggest players in the market in the future in Europe.
Do you think that investment, because along with it is a lot of investment in research and development and new product. Do you see new product and kind of technology coming out of Asia that you think is impressive, or there's because there's some fantastic innovations in the US and some of the stuff Tesla's been doing. Is really is interesting. There's in the UK there's some really notable new technologies coming in, interesting things. But do you see the same thing happening from the Asian market as well, where there's some real kind of amazing stuff coming?
Yeah, so some companies are looking very interesting. If you have a look on the solid state business, on the solid state cells, there is a lot of things going on, but I think it's worldwide going on, because everywhere on the world are good institutes, good university, which are having impressive developments. And I think the big deal is to grab this developments from the lab scale and bring it into production. And I think this is the most important step to be successful in the market. Grab new innovations, grab new technologies, and really bring it into the product of a cell. There you will be the first and the successful one in the market.
And it is something that's starting to be talked about more and more, because in the past, I think people thought the IP was the kind of exciting bit, and they kind of forgot about the manufacturing. So you'd be like, well, we've invented this amazing new whatever it is, but then actually going from lab scale in a uni environment or an R&D environment to even small scale production is quite a big jump. And it seems like with new technologies like electric motors, like battery cells, there's a huge amount of process technology that's needed and process capability. You can't just go out to a contract, a sort of generalist contract assembly company to do these jobs. There's so much coming in. Do you think that will continue? Do you see the manufacturing processes getting more and more nuanced and complex, or do you think it might end up going the other way, where it becomes easier and easier as the technology matures to make some of these things?
No, I think it will be much more complex concerning the processes,
right?
Because all these new materials, for a small example, you like these nickel-rich NMC cathode materials. In the future, you can have it just laying around on your office desk, and it doesn't happen to them anything.
Yeah.
But with this nickel-rich now, they are totally. If there's just a little bit humidity in the room, they are grabbing it and doing some chemical reactions with the air and with the humidity, and therefore the processes are getting more and more complex.
Yeah.
As well as if you have a look on new separators, if you have a look on stuff like what we are doing at the moment, also is pre-lithiation stuff. So if you have a pure silicon anode, for example, you are losing a lot of capacity during formation process.
Okay.
And all this lithium capacity is coming from your cathode.
Okay.
You somehow have to balance it, and therefore we are doing a pre-lithiation step in our coating process, which is very very challenging step during production. So I think in the future the processes will be much more difficult.
Yeah.
If you want to have a top level cell in the market.
Right. Okay, that's interesting. And then just finally, to kind of bring it to a close, really exciting time for you and your company. This amazing journey you've been on the last couple of years. What's what do you see? Where do you see yourself next year? What's got you excited for the future?
Yeah, so our plant now is more than 6,000 square meters of production hall.
Wow.
At the moment, there's some space left, as I mentioned. For cell assembly and for the big coding machines.
Yeah.
So I hope the next couple of years the space is completely full, of course. And I hope that, of course, all these machines are running like hell to produce electrodes and cells for our customers. And if you look a little bit more on the long term to the future, I just think about having a world fully driven by electric vehicles, by stationary power storage, and a lot energy just coming from renewable energy sources. Yeah, this is what I like to see in the future.
Yeah, it's pretty exciting new world coming with, I often say, the electrification of everything. Just on this podcast, we've talked about applications that people might not have thought about, where you're putting medical devices in people's bodies that need batteries. You're putting stuff in aircraft, drones that needs energy storage, grid, renewables, electric vehicles, hospital equipment, mobile robots. The whole the kind of this evolution that the better battery technologies are allowing more energy storage, which is then allowing more capable machines, which is then encouraging the development of more capable batteries, and it just seems at the moment to be an amazing cycle where almost every week I see a new application of something, and it's like, wow, you couldn't have done that 5 or 6 years ago, or maybe if you could have, it would have been just prohibitively expensive. So the future for electrification in all kinds of markets, not just automotive, is really exciting, and it's great to see you guys playing such an important role in it. And doing, I'm completely in awe of what you are doing in Germany. It's absolutely fantastic to see what you're doing at UniverCell. So thank you. So thanks Stefan. Thanks for joining me on the show today. It's been absolutely fascinating to learn about you and learn about UniverCell. I'll make some show notes, which I'll put down. So there'll be some links there. If you're interested in learning more, I'll link out to UniverCell and to Stefan, to his profile, and people can find more about you that way. So, but yeah, thank you. Thanks very much for joining us.
Yeah, thank you very much to be here and to speak to you. It was very nice. Thank you.
That's all we've got time for today. I really hope you got some value out of that and enjoyed the show. Don't forget, if you've got a question or you're interested in something to do with electric vehicles, send us that in via the comments or directly. Also, if you're doing something cool like Stefan in the EV world and you want to be on an episode of the podcast, do get in touch. Other than that, don't forget to subscribe if you haven't already. Hit like, it really helps us get the show out there. We've been getting some great reviews recently as well, so please, if you feel motivated to do so, leave a review. And I really look forward to speaking to you again soon.